Well, they can hear you now that it's recording. That was the countdown. Okay, so the proof of the Pythagorean theorem. And it does, like I said, it says one of many, because there are lots of different ways I can prove this. Because it's a pretty solid rule. We're going to start with a right triangle with legs A and B, hypotenuse C. Where our goal is to prove a squared plus b squared is c squared. So what we're going to do is we're going to look at this square that we've got here. If I look at the shapes that I'm looking at, this side, right there, how long is that? No, a side is not 180. That's okay. Now the angles would add up to 180, and that does apply here, and it's their right triangle, so I can use those rules. But if this length is B, that length is A, how would I describe that length? A plus B. And that means this length down here would also be A plus B, right? Now, you might not know where I'm going yet, but that's okay. Let's talk about the area of that square. I've got this square. It's right here. I've got this side is A plus B. This side is A plus B. So how would I find the area of a square? Base times height, multiply those together, yeah. So that's going to be A plus B times A plus B. So far, so good? Okay. No. No? Okay. Yes. Well, remember, all I've said so far is here's a square. This side is A plus B. This side is A plus B. So the area is base times height, which is that. Now I'm going to FOIL it out. A squared plus 2AB plus B squared. When I do FOIL, that's what I'm going to get when I simplify it down. When I FOIL it out, so A times A plus A times B plus A times B plus B times B, I get A squared plus AB plus AB plus B squared, and these guys combine to 2AB. Because when I FOIL it out, A times A squared. A times B, AB. All right, there we go. That's all right. Now, while we're talking here, let's take a look at this box a different way. I've got this middle square right here, right? Somebody help me out. What's the area of it? Each side is C. So what would the area be? Okay, so the area of that inside piece is C squared. I've got this triangle, right? What's the area of a triangle? That's 180 is the sum of the angles in a triangle. The area of a triangle. I have a triangle. Tell you the base, the height. What's the area? Base times height divided by 2. Because you guys should know the area of a triangle. Yeah. That is true. 7th grade was a while ago, but it's all right. So that means the area of that triangle in green, 1/2 base times height. And I've got 4 of those, right? Times 4. So that's the same as saying C squared plus 2AB. All I did there was I just cleaned up that. I've got 4 of these green triangles. I've got 1 big square in the middle. So the area of the whole box is going to be c squared plus 4 of those triangles. Cleans up to this. Well, that's two ways to describe the same area. So let's set them equal to each other. I can say a squared plus 2ab plus b squared is the same as c squared plus 2ab. Is there any way I can make that look like what I want to look like a squared plus b squared equals c squared? What can I do algebraically to get there? Yeah, subtract 2ab from both sides. And now that means I'm down to that. And so those are going to cancel. So what I've shown here is that if I take this picture, which is a square that I can break into 4 triangles and the inner square, I end up with one way to write the area, another way to write the area, and when I say those are equal, because it's the same area, I get the Pythagorean theorem. So that's one of the proofs that shows that a squared plus b squared is going to give you c squared.